Hey, this is Mr. Barr, and this is the practice test for graphing functions part what? Let's graph some functions. So we have this upside down parabola, and we want to just talk about the domain and the range. So the domain is all real numbers. Yes, this is all real numbers. If I took this and smeared it onto the x-axis, it would cover up everything. So the domain is all real numbers. The range is everything below 2. It's actually from negative infinity to 2, or everything below 2. So the range is y is less than or equal to 2. So those are the two correct answers there. This one, let's answer some questions about it. It's based off of a word problem. The graph below models a kid standing on a small wall, throwing a ball up in the air, and the x-axis represents time, and this is height. So he throws up a ball, and 6.5 seconds later, it's on the ground. Based on the information, select the statements that are true. Okay, true. Before being thrown, the ball is already 3 feet off the ground. That is correct. It's 3 feet off the ground right there. The y-intercept indicates that the ball was in the air for 6.5 seconds. The y-intercept? No. That means the ball was 3 feet off the ground when it started. The ball had a maximum height of 12 feet. Yep, that's correct. The x-intercept indicates that the ball was in the air for 6.5 seconds. Yep, up in the air, hits the ground, 6.5 seconds. The y-intercept indicates that the ball was in the air for 3 seconds. No, that means it was 3 feet off the ground when it started. At the end of the throw, the ball is on the ground. Yes, boom, it's on the ground right there. We are going to graph this equation, which is f of x equals 2x plus 3. I made a little t-table. I plugged in a 0, got out a 3. I plugged in a 3, got out a 9. I can then plot those points, 0, 3, 3, 9, and connect the dots with a line. This one we're going to talk about intervals where it's increasing, decreasing. Notice it's increasing here, decreasing, increasing, decreasing. Select the false statement. The graph is increasing from 7 to 10. 7 to 10 increasing, that's true. The graph is decreasing 3 to 5. 3 to 5 decreasing, true. The graph increases and then decreases from 7 to 12. 7 to 12, increase, decrease. The graph increases and then decreases from 3 to 9. 3 to 9, decrease, increase. And this says increase, decrease. This is false. You are standing on a 5-foot wall. You throw a ball straight up in the air. 2 seconds later, the ball reaches its high point of 12 feet. 3 seconds after that, it hits the ground and begins to bounce. 1.5 seconds later, it reaches the high point of the bounce at 4 feet, and then 1.5 seconds later after that, it's back on the ground. Sketch a graph of this. Here's my graph. So we start at 5 feet. 2 seconds later, we're at 12 feet. 3 seconds after that, we're back on the ground. We're at the ground. A second and a half later, it's at 4 feet. A second and a half later, it's on the ground. Second and a half, actually one, that feels like it's off. It is off. It should be 1.5 seconds, and then 1.5 seconds should be right here. There we go. Select the graph that correctly represents this function. So I made a quick t-table and I plugged in a 1 and a 0. So if I plug a 0 into this, out comes a 1. And if I plug in a 1, out comes a 1.5. Notice it's only positive numbers. So it can't be this one because these numbers are not positive, so it can't be this. It would only be from here to there. 0, 1, 1, 1.5. So really what we're looking for is this chunk right here, which matches up right here with B. So it's B. Create a graph that models this situation. A hiker is hiking down a 150-foot hill. She descends at a rate of 15 feet per minute. So it's actually going to take her 10 minutes to get down. So she starts here, 10 minutes later, she's on the ground. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Another domain and range function or problem. So the domain of this, if I smush it down, is everything except 4. And the range of this, if I smush it sideways, is everything but 6. The domain is all real numbers not equal to 4. The range is all real numbers not equal to 6. Absolute value function. I'm going to make a t-table and throw in values. If I throw in a -3, out comes a 14. -2, out comes an 11. -1, out comes an 8. 0, out comes a 5. 1, out comes a 2. 2, out comes a -1. And 3, out comes a 2. And right here, you can see I hit the vertex. So I plot those points, and I get the absolute value function. Right? I plug in, let's plug in a 1. Plug in a 1. 1 minus 2 is -1. Absolute value of -1 is 1. Times 3 is 3. Minus 1 is 2. Plug in a 1. Out comes a 2. Okay, let's see how this works with Edulastic. Number 1, we said it was A and E. Number 2, we said A, C, D, E. A, C, D, E. Number 3, I'm just going to take a couple points. That's 1 point, and the other one is 0, 3. There's the line that we drew. This one, we said it was D. This is that graphing one. Edulastic's going to have an issue with this. And use this curvy tool. So I start at 5 and I go to 12. 5 to 12. 3 seconds later, I'm on the ground. One and a half seconds later, I'm at 4 feet. Then 1.5 seconds later, I'm on the ground again. There we go. That kind of models it. It's not beautiful, but it's good enough. This one, we said it was B. Next one. So we're going to start at 150 and be down at the ground after 15 seconds. This was A and E. An absolute value function. And this thing, once again, it can't handle one of those questions. We got that one right. Did I mess up? Did I mark that? I'll have to watch the video. The y-intercept indicates that the ball was in the air for 3 seconds. That doesn't. I must have marked that by accident. I can go back and watch the video. That looks good. That looks good. That one, it's not holding it. Edge elastic is messed up. That looks good. This one, it did not give me credit for that one. Why not? I'll have to go work on that one. And number 8 is good. All right, hey, that's it. Thank you for watching.